Hello and welcome to today's lesson all about seismic waves for GCSE physics. The first thing that's linked to seismic waves is of course earthquakes. So what we know is that earthquakes are generated in the Earth's crust. And we say the place that they originate from is known as the focus, and then the epicenter is the nearest point on the crust from where it originated from. And we use seismometers to detect the earthquakes, and that's the thing that gives us squiggly lines that we might use to represent the seismic waves. So what are the different types of seismic waves? Let's take a look. We'll start with the P waves, or the primary waves, or the pressure waves, P for all of those things. They're the ones that arrive first, which means they're the fastest. And they're also the longitudinal waves. That's the one that looks like a barcode. The secondary waves arrive second, after the primary waves, so that means they travel slightly slower. They're a transverse wave, so it's got an S in, the word transverse, to help you remember that, and we'd call that a shear wave. Although secondary waves are more dangerous than primary waves, perhaps the most dangerous ones are the long waves, and they're the ones that arrive last, so they travel the slowest. And what happens is they provide violent movements that go up and down, as well as backwards and forwards. Although earthquakes might be seen as quite a dangerous thing, they do actually provide science with quite a lot of information about the structure of the Earth. Let's take a look. P and S, or primary and secondary waves, they bend as their speed changes as they go through the Earth. So at the top here, we've got the epicenter, and that will release a number of different waves. So I've just drawn some of them on, so the ones in red I've drawn as the P wave, and the ones in blue as the S wave. And as we can see, they travel through and they bend, so they can then be detected by other seismometers around the Earth in different places. By looking at where the waves come from and where they go to, that can tell us lots about the structure. So what we know from this is around the edge we have the crust, in the yellowy orange we have the mantle, and then we have the inner and the outer core, and we can use P and S waves to tell us what they're made of. What we can also detect again by seismometers is that the P waves, when they hit a part of the Earth, the outer core, they refract again because it's a different medium, and then they pass through, and as they leave they refract again and then can be measured by another seismometer. So at different boundaries, the P wave refracts. Something else that we've noticed is that the blue line, or the S waves, they don't travel through this green part here, and that tells us that the outer core is made out of a liquid. S waves travel through solids only. They cannot travel through the liquid outer core, so S is also the solids only. We'll come back to this diagram shortly, but for now, let's just refer to the idea of a shadow zone. So we mentioned a second ago that S waves get stopped when they go to a liquid material. And likewise, we mentioned that P waves bend a lot when they pass through different mediums. And what that means is there are areas of the Earth that after an earthquake do not perceive any seismic activity, and they're called a shadow zone, an area where no earthquake wave reaches. So in my diagram, I've just labelled it in a slight purpley pink colour just there, just to represent the idea that this bit here and up will receive seismic activity with seismometers, and there'll be an area afterwards that does as well, but there'll be a gap because of the refraction that takes place, plus the S wave will not be able to pass through just here because that's all made out of liquid. So that's called a shadow zone. More evidence about the structure of the Earth is that we get weaker P waves when they pass through the inner part of the Earth, so that tells us again that it's solid. And finally, we know about the crust and the depth because the speed of the wave changes at about 50 kilometers deep. So that's roughly how many kilometers deep our crust is around the Earth. You've now reached the end of the video. Thanks for watching. Don't forget to subscribe, and as ever, if you have any questions, please get back to me. Goodbye.